last thing for today is non-homogeneous equations. So that's the one other thing that we want to talk about today, non-homogeneous equations. And I guess it would be non-homogeneous systems of equations. Okay, here's my recall. We can make a system of equations look like this, right? Vector x prime equals p of t times vector x plus vector f of t. That's what a system of equations is going to look like. Yes, that's how we wrote it yesterday, system of equations. All right, remember that this is, yesterday we did homogeneous, so today we'll say non-homogeneous. This is non-homogeneous if vector f of t is equal to 0. And this is a vector on the left-hand side, so it also has to be the 0 vector on the right-hand side. If you took Calc 3 with me, if you took linear algebra with me, you should be very comfortable with me asking scalar or vector. Has to be a vector. If you remember what we did for non-homogeneous equations with the characteristic equation, we are going to say that x sub c vector. Daniel, question first. You might be muted. Or you just raised your hand randomly.
Homogeneous if f of t, or non-homogeneous if f of t is not
equals, not equals, sorry. There. Thank you.
Yeah.
Yes, non-homogeneous if f of t is not equal to the 0 vector. Thank you. Okay, so x sub c is a general solution to the associated homogeneous equation. This should look super familiar, except it's a vector instead of a function in this case. Vector x sub c is a general solution to the associated homogeneous equation. C, remember, is for complementary. This is the complementary equation. Vector x sub p is a particular solution to the non-homogeneous equation. Again, should look super familiar, except it's a vector x sub p instead of a function x sub p. Then x, which is a general solution to the non-homogeneous equation. Totally the same thing as what we did back in chapter 2. This is just with vectors, vector x sub c plus vector x sub p. Here's the problem, and the reason that we're not doing a ton with non-homogeneous systems of equations. Problem number 1 is I don't have enough time in the semester. But problem number 2, do you remember when we did undetermined constants and you had to say, well, I want it to match with the right-hand side of the equation, but I don't want x sub p to match with x sub c? This gets more complicated when you have vectors, because you have to worry about all of the individual rows, the functions in the vector matching or not. And so there's just more going on here because there's more stuff that you have to match and also more stuff that you don't want to match. We're trying to balance those two things. So this is more complicated than it is for just a single non-homogeneous differential equation. If I had another week to 2 in the semester, I would probably teach this. But given that we're short on time and that it is more complicated, we're just introducing you to the basic idea and then saying, we're gonna stick with homogeneous systems of equations, okay? So it's just a quick intro, but that's where we're at. All right, on Wednesday, tomorrow, Wednesday, we are going to do magic. So that is the step that is left in this process. Yes, all I've been doing, and I don't remember, I think it was maybe Grant, not positive, asked today, where did these equations come from? Magic, totally magic. Tomorrow we are going to learn how to do magic. How are we going to come up with these vectors x1, x2, x3? And that's kind of the main topics that we're going to cover for the rest of the semester. We're going to look at the super absolutely ideal case first where everything works out well, and then we're going to look at what happens when stuff goes wrong, and that's sad. So that's the sections 5.4 and 5.6 that we are finishing up this semester. Anything for questions, roadmap as to where we are going, idea as to where we've been? Anything? Great. I can make roast guinea pig in case getting a guinea pig is not a good idea. Thank you. I feel like we never left the classroom with the side comments. I do appreciate that. Thanks a lot. Other things. Anything else? Goodness. Okay, I'm going to send out homework, and I'll make this clear in the homework, but you can't use matrix operations on your calculator. You have to do the matrix operations, the elementary row operations by hand. So there's going to be 2 of them, like the problem that we did today. Take your initial conditions and find your particular solution. You got to do it by hand with an augmented matrix. That's my plan. All right. I have virtual office hours this afternoon. If you want to see me, I will just be on Zoom working, and you are free to pop in. Homework's due on Friday. The last stuff that is due on Friday will be emailed out in just a couple of minutes. Going once, going twice. Anything else for questions? All right. Thank you for playing my virtual online math class. It's been way too long, and I'm ready to be done with this game. See you tomorrow. Bye, guys.